in the diagram, TSR is the diameter of the larger circle having center S, right? So TSR is now my diameter. TSR is the diameter of this big circle. So as you guys can see, we have two circles. So let's all now. So okay, and then what else are they saying? And already, if now before we go far, if TSR is my diameter, that means this guy is this is my center, right? Okay, we know that. But then these are radii, so they are equal in length. Yeah? From them there, we also know that what's this? This guy is gonna have to be 90 degrees. TQ of the larger circle cuts the smaller circle at M. So it is visible, né? Called TQ of the larger circle cuts the smaller circle at M. So here it is. Here it is. And then what else are they saying? PQ is a common tangent of the two circles at Q. So PQ, this guy here is a common tangent. SQ is drawn. Here's our SQ. Basically this line here. Then now we are told that RP is perpendicular to PQ. Right? So RP is perpendicular to PQ. And then MS is parallel to QR. So okay, we read our stuff there, no problem. But then we also have parallel lines. Yeah? So you remember, whenever we have parallel lines, we must always think of our funny going to apply them. 10.1, prove giving reasons that 10.1.1 SQ is the diameter of the smaller circle. For Tramax, no? So we are gonna leave Tramax for this one. So we won't really have to apply a lot of processes and whatever, but we still have to apply something. So we want to show that SQ is the diameter of the smaller circle. Here's my first question, and I think even yesterday we had a question like this. For this guy, for SQ to be a diameter of the smaller circle, what must happen? Yeah? That's the first question I must ask myself before I go very far. What I can see so far is that M2 has to be 90 degrees. So if I can prove that M2 is 90 degrees, then therefore we can deduce that what's this? SQ is the diameter of this circle because it is the one that is subtending M2. Yeah? Is that clear, right? We had something like this, so yeah, I'm sure it's not foreign to you guys. So okay, what do I have? Ne? Let's start there. Let's start there. If I can see number one from my big circle, TSR is my diameter, right? And as we said, TSR subtends now angle TQR, which is this guy. So already I know that angle TQR is equals to 90 degrees. And then what is my reason for me saying TQR is equals to 90 degrees?
Okay, angles in a semicircle.
Yeah, exactly that. Angles in a half circle, in a semicircle. So sharp. But then what I'm also seeing now is that, okay, since now MS is parallel to QR, né? Let me even do it like this. MS is parallel to QR. So what it's telling me now is that I can use now my co-interior angles and actually prove that this guy is 90 degrees. So now I can say, okay, M2 is equal to 90 degrees. Well, my reason will be co-interior angles, right? Given that MS is parallel to QR. Yeah? But then to answer my question, I have to say, therefore, SQ is a diameter of the smaller circle, because that's what they are asking. Yeah? SQ is a diameter of the smaller circle. And then my reason now, if this guy is a diameter, then if this guy is a diameter, then you know a diameter, it always subtends 90-degree angles. Yeah?
Yeah.
So it's going to be a converse, but then of what? Angles in a half circle. Or even because we have different reasons. Né? So another person could say it's the converse of angles subtended by a diameter. That's still a correct reason. So even here we could just say angle subtended by a diameter. Right, so already we see they are awarding 6 marks. And then now they are saying we must prove given reasons that RT is equals to RQ squared né? Over RP. Let us look at those lines specifically. RT, né? So here's my RT is equals to what? Is equals to RQ squared. So it is equals to RQ squared, which is this guy here, over RP. And here's my RP. So me highlighting these lines is also helping me, to make sense of what I have to do. All right. So sharp. How will I be able to achieve a RQ squared? Ne? For me to achieve RQ squared, I must have RQ times RQ. Then that's just gonna give me RQ squared. But how will I get that? Because I only have one RQ, right? I only have one RQ. But then one thing, whenever we have a question like this, which are now talking about the size that we have in the diagram, because it's only size, there are no numbers and whatever. So here it will just have to be pure application of my theorems. But then specifically for a question like this, Eloring, it only sides. There's no numbers. You see, because if we look at 10.2, then we have now PQ is equals to root 40. There's numbers now. And you could say, okay, if it's root 40, then maybe I must use Pythagoras. You see, something like that. But we can't use Pythagoras with sides only. There should be numbers. So with this now, specifically a question like 10.1.2, 9 times out of 10, we must firstly prove a similarity, né? Because we know a similarity, there's only two ways, right? It's angle, 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 or what? Corresponding sides are in proportion. Yeah? So it's only one of two ways of proving similarity. But since we are dealing with angles now, because it's Euclidean geometry and we don't have side, then we are gonna prove it by angle, angle, angle. Then once we have proved the angle, 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 now we can go to our sides. Yeah? So for instance, I'm not answering this question. So let's say I have this guy, A, B, C, D, E, F. Yeah? And then I am told that A is equals, no, B is equals to E, and then A is equals to D, then proof similarity, all right? So I'll just say, okay, A is equals to D given, and then I'm going to say B is equals to E, and even added is also given, right? But then lastly, I'm going to say C is equals to F. What will be my reason for me saying that? I'm
Side
asking
angle.
that angle. Yeah? So therefore, I can say now a triangle. But please look very carefully. Yeah? I'm starting with this one here. So I'm going to say triangle ABC is similar to. Look at what I'm saying it's similar to. I'm saying it's similar to triangle DEF. DEF. Why? Because A now is equals to D, right? D is equals to A. Um, B is equals to E, and lastly, C is equals to F. Okay? So I must write my angles according to their corresponding equals, right? So if now I were to have, I was going to write it like this. If I was going to say, okay, triangle CBA is similar to, I can't just say it is similar to triangle DEF. I must say it's similar to triangle FED, right? So you see there's a way that we should write these things. Eh? Then my reason is just gonna be angle, angle, angle. So now from here, eh, I can deduce the following because now once I have proven that they're similar with angle, 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 automatically it also means what the corresponding sides are in proportion, right? And also for corresponding sides to be in proportion, that would just mean, let's say now if we have something like this, né? Basically something like this. So I'm just gonna say now from what I have here, guys, I'm just gonna be able to say the following based on saying that they are similar. So I know I have triangle CBA, and it is similar to triangle FET. So I can get the following. I can have, now I know that CB is corresponding to FE, right? And let's see, CB, here's my CB, it's corresponding to FE. From the way I wrote them down, I can deduce the following. So I can say CB over FE is equals to, number 2, BA is corresponding to what? ED. So it's equals to BA over ED. And then lastly, it's going to be CA being corresponding to FD. So that's CA over FD. So I also wrote some numbers on my side. So if I say now CB, I know it is 6 over, and then over what is this? FE, which is 80, which is now equals to BA, and my BA is 3, over ED, which is 9. And then lastly, it's going to be CA, which is 5, and then over FD, which is 50, right? So if I were to simplify all of these guys, I would get 1 over 3, 1 over 3, and 1 over 3 for all of them. So that's what we mean when we say corresponding sides are in proportion. You see? But then now we do not have numbers there. For this question, we don't have numbers. We are only dealing with sides. So our solution now would come from here. After proving similar triangles, our solutions would come from here. As I said, 9 times out of 10, we are gonna have to deal with it like this. So, okay, let us jump into answering the question.
Part 2 will be discussed in the next video. For now, subscribe and go practice mathematics. You are writing paper 1 on the 3rd of November in case you forgot. Are you still here? I'm gonna have to tell your teacher that you're busy lazying around. Follow me on Instagram at Sebas Tutoring Academy, then go and practice mathematics.